Hey there. So before I start, I always like to introduce with some musical number. So enjoy. Midnight, not a sound from a pager. Servers running a Rust code, gently humming along. Wistful hackers are longing for a way to break in, but our safety, is too strong. Memory rust is keeping it safe and obviates data races without runtime increase. No GC to stockpile it, our code can have it all to run with it as we please. Burned out JavaScript programmers pining for the fair days when requests came in the tens per second, unless /dot crossed their ways. This ode's dedicated to Rust code running on our servers or in somebody's cloud, on our desktops or in the OS driving our phones. As a new day, we'll find out. I hope you're awake now. So, I had hoped that I could mirror the display. Unfortunately, that doesn't work. So I'll have to look there to see what I'm typing. I hope that'll do. So what is a semantic search? Basically, the idea is that we take some text, the input, and also the thing that we search in, and we transform it into a mathematical representation, basically a vec of floats that we can search on by some metrics, which in our case will be cosine similarity. And to do the transformation, this is the first thing I'll be doing. I'm using RustBird, which is a crate that offers an easy pipeline for embedding. I sure hope the network works. Okay. Now. Oops, too much. That's the downside of not seeing what you type. For that, we obviously also need to change the return type to result.
Do you want to maybe rotate the thing?
That's probably a good idea.
Yeah. It's a way bug. So
sorry. So this is the first thing we'll do. I just have some sentence that I'm going to embed, to encode using this model. Also, I need to return an OK here. And what's wrong? Yeah. Thanks. Okay. And the first thing is, okay, this is out. Obviously, it doesn't take just one input, but it takes many of those. So we'll just have to give it one. So, and then if that works, we'll have our embeddings, which are not very interesting. That said, what we can do with them is we can insert them into a vector database, such as Qdrant. So let's first get a Qdrant client. Oh no, I'm just using a bar. Sorry for the unwrap, but I want to be fast here. Usually you would do something like this. Why did it do that? What's wrong with it? Oh. Ah, so it did an if there. Well, that's weird. Anyway, and I probably need to import that.
You need to overwrap the second bar and bar.
No, I don't need to unwrap it. The nice thing here is that I did a PR to the Qdrant client library that gives me the option to just use a result there and it will unwrap it directly. Okay, so now we have a client. We should look at what we're given. So the way I want to do it is I look at the first argument, and first, so we can search something, we must have something. So let's first implement insert. Obviously, some insert. We have to get the types to line up. Why doesn't it like that? That's why. Okay, so first, I already have created the collection, but I want to recreate it here because I tried this out this morning. So I'm not taking the return value here because I'm not interested in if that works. If the collection isn't there, it should run anyway. Then we need to recreate it. So we can ignore most of the other things. There is one thing that we need to care for, and that's the vectors config. All the other stuff we can simply use default for. Oops. And now we also have to await this because, what is that? It also needs to be. This is because the now we've created the collection, and then we have to read the input file. Just copy that. We also need some IDs here. So I'm just using a counting integer. And now we have to create a number of point structs that will be pushed into the database. This file I'm going to use is a JSON-L file. And since Qdrant accepts JSON payloads, I'll just use the file directly. Here I'm going to unwrap because I'm not going to do the result of item to result of vectors to keep it easy. Now I'm going to embed that. And here we have the problem that we have a vec of vec. So I'm just taking the first element. And creating a point struct. Not point struct, it's point struct. There we are. Now we can just collect this, say to a vec. Now we can, it's called upsert, basically insert or update if it's already there. But I don't want to do it at once because then I might run into timeout. So I'm chunking this to, let's say, 100 points at once. Let's perhaps also, oops. Just print a dot. What does it like here? Oh, yeah, of course. The S is missing here. now we see that we need to be async, which we will just become by using the Tokyo main attribute. And we also need to make it async. It's really hard if you cannot really see what you're typing, but I'm always missing semicolons. That's really, it's a pity. I also need to put this into args. I probably also should import hash map. And there we are. So now we can that's the first problem. Tell me that. Fair. Now this will take a while. No, it doesn't. Not present. Of course, I was missing the Qdrant URL variable, so I should set that to let's try again. Next problem. Okay, so collection point exists, but I thought I had deleted it.
You probably have awaited the deletion.
Yeah, probably. I failed to await that. Yeah, that's a problem. But the good thing is that once that works, I have the Qdrant log open here, and it seems like it does something. So it deleted and created the points collection. Yeah. So now it's embedding the whole stuff first, and only then it's inserting, which will then run pretty fast. So that's why we're not seeing anything. In the meantime, I might just tell you a Rust joke.
What's funny, can I ask why the model takes an array of strings rather than just a string?
Well, this is just an implementation detail of the Rustbird crate. Oh, and we left I left the embedding of my, Ferris in there, so I probably want to remove that. Because now we want to do the actual search. Let's call it find, because that's shorter than search. semicolon. And we will always have one vector here, so keep missing this. Already in. So there's a lot of stuff we could do here, but I'm not going to do it. Just limit is something, and with payload is also something that we want to have. The rest I don't care. So just use the default. And I guess we can just print it for now, because I'm already pretty late. Oops, that's the wrong bracket. So now, let's see if we can find something. For example, Qdrant is pretty bullish on quantization. Oh, that's the next problem. I missed that. Obviously, I'm missing things. Needs to be some find, or else the type is not correct. And there we are. So there are some texts within the documentation of Qdrant that are about quantization, even if I was searching for quantize. So you can see it's not directly a word search, but it's really a semantic search. So, surprise, it works. Yeah. So I had promised you a Rust joke. So what does a Rustacean call a gopher? Hi, friend. Yeah, I was faster than I expected, actually. So even with looking over there, and then my neck is getting.
You got questions?
So the question was if I could go through some of the parameters I set.
Yeah, like especially, I think you used 384 as the embedding size. Is there any rationale behind that?
Yes, both the size and the distance measurement are innate to the model I'm using, which is this mini LM L12V2, which is a BERT model that has an input size, or no, it has an output size of 384 floats, and uses the cosine similarity metric, which is what this is about. This is why I had to configure this, because there are some models that use say, dot product as a metric, or they have their own custom metric. This is also supported by Qdrant.
Thank you. For those of us who aren't that familiar with Qdrant, could you maybe give us a little bit of background on that? Like, is that free to use? Is it only like business facing?
Yeah, so the nice thing about Qdrant is it's a vector database that is very performant. So it's pretty fast. It's also pretty scalable. You can run it on your own PC, as I have done right now, or you can just get a free tier server from them, or pay for it if you really want, and if you really need to scale out. You can run it on the cloud, run it everywhere. You can connect to it via gRPC, which the Qdrant client crate does. It's basically just a wrapper around that gRPC interface. And since it's all written in Rust, yeah, it's pretty easy to set up. The only downside to me is that the gRPC interface doesn't look quite that rusty. As you can see, there are a lot of sums in there, because for gRPC, for protocol buffers in general, all fields of a protobuf struct needs to be optional. So yeah, that's an unfortunate downside of using protobuf. On the other hand, it makes it very easy to access the database from most every programming language that you could find of. And in AI applications, Python is often used. I also see a lot of TypeScript. I even see some people using Java, of all things. But yeah, so whatever floats your boat.
Do you have some recommendations on the embeddings that one can use for cheaper, let's say, for more hobbyist projects?
Yeah, so those BERT embeddings, they're pretty well established by now, and they give reasonable results at very good speed. So this is just using PyTorch under the hood, or via the TCH crate, so directly interfacing libtorch from Rust. I have also tried this with ONNX runtime from Microsoft, which is a bit faster. And recently I tried out Candle from Hugging Face, which is a bit slower than ONNX runtime for now, but is written in completely Rust, so 100% Rust, no shelling out to C++ code, which is nice. And I really hope that they get faster.
Thanks.
Questions? Who wants to know how bigger it is? Like, huh? Like, I think it's the biggest screen someone live coded at. Like, questions? No? No?
So I think you passed some file to the program you wrote. Was it just a text file with like text lines? I think it was like some JSON,
JSON-L.
Right? Was it like
there's one JSON entry per line.
Okay, it was just like a random example.
Yeah, this
could have
just
been banana, apple, and
you could put everything into there. So basically, what Qdrant does is you can insert a point that needs to have an ID. It needs to have the vector, obviously, because otherwise you couldn't search for it. And you have a payload that is basically what I showed here. That is what the output was like. That can contain arbitrary values, basically using something akin to JSON objects.
Okay, thank you.
In the output, there was a CSS selector. What was that about?
This is just so that, well, this example is also used from Qdrant's homepage search. So if you go on the Qdrant page and click on the search box, then you will connect to a service that does something similar like this, just a bit faster, obviously, just a bit more optimized, and will do a search as you type on that, using all sorts of tricks to do this in mere milliseconds.
Okay, thanks.
So when you do a find, does it do inference on your GPU there?
Sorry, I didn't quite get this.
Like you need to embed your strings that you're going to find.
Yeah, this is what the encode method does. Here.
So it's using PyTorch under the hood for that, right?
Yeah, the TCH crate calls directly into libtorch, so it doesn't use Python, but basically it's the same thing.
I was wondering, like, what's the performance of that? Can you, like, how scalable is that?
Yeah, so this is using CPU as far as I know, so it's not that fast. I just used it because it's the crate that allows me to have an embedding pipeline with as few lines of code as possible. So again, if I were to do this for speed, I would use probably ONNX engine or something similar. There are various engines right now for embedding. Intel has OpenVINO, Hugging Face is doing stuff, Microsoft's doing ONNX engine, obviously. So those are all fine options.
Thank you.
Questions?
Yes, thank you for the guideline how to use Qdrant. Yeah, basically I never use it, but does it support the image similarity in the sense?
Sorry, what similarity?
Image similarity.
So the thing is, if you have a model that embeds images, then of course you can do a similarity search on those embeddings. It doesn't matter what the input is. I mean, a colleague of mine has done an audio search where you can really sing into the mic and get some song that sounds quite like it. Or you can do a recipe search for various things, or you can do a video search if you have a model that supports that.
Okay. For the next question will be about Qdrant itself. Does it how it's scaled basically? Does it actually store those embeddings into memories only, or is it into files?
So
how it's expressed is?
Everything is written to disk. There is also the option of keeping stuff in memory, which is also the default because usually you'll want to have that. However, those embeddings can take up quite a bit of space. So Qdrant is, as I said, very bullish on quantization, which means you reduce the size of those vectors by not storing full floats, but perhaps only storing bytes or even bits, and also reducing the number of values by some clever algorithm that you store. And then you can do an initial search on those reduced vectors that will give you a pretty good idea of where things are. And then you take the top n that are more than what you actually need. And for those, you get the actual vectors and do a real similarity search, which will give you very good results with far better performance.
Okay, thank you.
Anybody?
Yeah, so in this example you made, you're using cosine similarity. What about other metrics you could use? So for instance, I believe for full text search, like I was working on it for a while, for a full text search database, I think A10 SW, so like a hierarchical or navigable small word, was kind of the state of the art last year. But this field is moving very fast. Do you have any recommendation of which kind of distance metrics to use? And also, like, do you need to use different metrics depending on the use case, or can you just use the same one with several different use cases? Thank you.
It very much depends on what you've trained your model on. So it doesn't make sense to use a Euclidean distance for a model that has been trained against cosine similarity, of course, because your results will be unusable. But in fact, cosine similarity is something that has worked out reasonably well and is not that expensive. Of course, if the distance measurement becomes a bottleneck for you, then you might want to train a model on, say, a dot product or so that can be calculated much faster, or even the Euclidean distance, but that's that doesn't give you that much information from the inputs that you have.
To follow up on the previous question on scale, does Qdrant do more linear search, or does it try to batch inputs by clustering them or something like that? Or does it have some way of reducing, of doing stuff like a binary search or or things like that?
Obviously, it's not doing a linear search because that would be pretty slow. What it's doing is called hierarchical navigable small worlds, which basically means that you have a kind of tree of meta nodes that sit in the midst of some clusters, and so you first search for the cluster, then you look for clusters within clusters, and so on until you reach the points where you can look into the neighborhood. So just like you would do a map search by first looking for the continent, then the country, then the state, then the city, and so on.
Thanks.
Do you support also product quantization to reduce the size of it?
Yes, there's scalar quantization and product quantization.
So I don't know very much about this vector search engine stuff. Would it make sense to use this to build like a fuzzy search for, I guess, maybe if you've got users on your profile to search for usernames, or is that a bad use case?
I have no idea why you would try a fuzzy search for usernames, but I mean, if you want to do a fuzzy search that is just for, okay, someone makes a small typo and mixes up 2 letters or so, then you will likely be better off with an FST-based approach that can do a Liebenstein distance or something. But if you want to have a search that is not fuzzy, but in a way clever, in that it will find words that you didn't search for but have similar meanings, then semantic search is for you.
So it would probably find users, if there's a user named Red and I search for pink, it would find the red user probably, right?
Yeah, so
okay.
For example, if you want to search for hospital and get also an ambulance, then you will want semantic search. Okay, even so though hospital and ambulance are widely different words if you just look at the letters.
I see. Thank you.
Thank you. You mentioned about HNSW data structures. I wonder how big it is actually the per cluster, the amount of embedding that can be within that one cluster.
That really depends on a number of factors. The first obviously being the space on disk that you'll need, and also the space in memory. So if you have small payloads and not too large vectors, then I think you can easily store a few million points per machine. And Qdrant has customers that go beyond 100 million points in a cluster, so multiple hundreds of millions of points, even to going to billions of points.
Thank you for the presentation. Do you use GitHub Copilot?
No.
Thank you.
So, okay. In 10 minutes there will be a coffee break. I think it's not open yet, but like 10 minutes and you'll be there. And Andre Bogus, right? Thank you.